Hello viewers, welcome to EduTube. In this lesson, we are going to learn division of whole numbers using reduction method. That means you are going to learn how to divide numbers using reduction method. So, our first example, we are going to divide 128 by 32 using reduction method. So to divide 128 by 32 using reduction method, we basically just rewrite the number as a fraction. So that means we'll write 128 over 32, making 128 the numerator and making 32 the denominator. So now I haven't expressed the two numbers as a fraction, so it's time to reduce them. Now to divide the two numbers using reduction method, the first thing we'll need to consider is their common factor. What's a common factor? A common factor is a number that can divide the two numbers both at the same time. So what's the common factor of 128 and 32? The common factor could be 2 and it could be any other number. But I urge you and advise you that you always start from the most famous prime number, which is 2. So 2 can divide 128 and 132. By the way, how did I know that? So according to the divisibility rule of 2, 2 can divide all even numbers and all numbers that end with a 0. 2 can divide all even numbers and all numbers that end with a 0. So how do you know an even number, especially when you have more than one digit number? Just check the last digit, and if the last digit is an even number, that means the entire number would be an even number. So in this number here, we have 128 ending with 8. 8 is an even number, so that would mean that 128 is an even number. 32 ends with 2, so 2 is an even number. That would mean that 32 can be divided by 2. 32 is an even number. So now that we've decided that 2 can divide both numbers at the same time, so it's time to reduce them. So to reduce, first of all, you start from the denominator. We are using 2 to reduce the number starting from the denominator. So if I want to reduce 32 using 2 to divide it, so I'm starting from 3. So 2 in 3, that will give me 1 remainder 1. So I'll attach the 1 to this 2, making it 12. So 2 in 12, that will give me 6. So I've reduced 32 to 16 using 2 as its common factor. Then I'm going to reduce my numerator. So 2 cannot go in 1, so I will attach the 1 to this 2, making it 12. So 2 in 12, that will give me 6 without any remainder. And then the next number is 8, so I will say 2 in 8, and that will give me what? 4. So I've reduced 128 to 64 using 2, which is a common factor of both 128 and 32. Now the new numbers I have left is 64 and 16, so I'm going to write them out to ensure neatness and clarity. So I have 64 over 16. Now, if you are conversant with your multiplication table, you would already know that 16 can divide 64. And also, you would already know that 4 can divide 16 and 64. But I will not advise you to rush yourself. Take it bit by bit to ensure accuracy. Now, like we said, when we reduce 128 and 32, we said if the last digit is an even number, that means 2 is their common factor. So the last digit here is 4, making it an even number. The last digit here is 6, making it an even number. So that would mean that 2 can still break them further. So I'm starting from my denominator, which is 16. So 2 in 16, that will give me 8. And then 2 in 6 here, that will give me 3. And then 2 in 4, that will give me 2. So I reduce 64 to 32. Likewise, I reduce 16 to 8 using their common factor, which is 2. Now the next number I have now, the new number I have now is 32 and 8. Now like I said, for this level, I said if you're conversant with your multiplication table, you should already know that 8 can go in 32. But like I said as well, don't rush yourself. To ensure accuracy, take it bit by bit. Now 32 and 8 are even number, which means that 2 is still their common factor. That means 2 can still divide them. So I will say 2 in 8, and that will give me 6. And then 2 in 32, I'll take it bit by bit. 2 in 3, that will give me 1, remainder 1. And then 2 in 12, that will give me 6. So that means 2 in 32 is what? 16. So now I have 16 over 4. Pardon me, 2 in 8 is 4 rather. So I have 16 over 4. Now 16 and 4. Their common factor is both 2 and 4. 4 can go in both of them. So to save time, I will just straight away say 4 in 4, 1, and then 4 in 16, that will give me what? 4. So I have 4 over 1. So 4 over 1 is my next number. Now, any number divided by 1 will give you the same number. So 4 over 1 will still give me what? 4. So basically, I've divided 128 by 32, and my answer is 4 using reduction method. So that is that about example 1. Now let's look at example number 2. 672 divided by 48. 672 divided by 48, still using the reduction method. So I'll write 672 divided by 48. Now, this number here ends with 2, and this number here ends with 8. That means their common factor is still what? 2. But this time around, I don't want to use 2, so that you don't get too used to 2 and think that 2 is the only number or is the only factor that you can always use to divide. You can also use some other number. You can always consider some other number. This time around now, I want to consider 3. Can 3 divide 672? Can 3 divide 48? Now, to find out if 3 can divide 2 of them, we are going to need to learn the divisibility rule of 3. Now, the divisibility rule of 3 says that if the sum of the last 2 digits of a number can be divided by 3, that means the number can be divided by 3. So the last 2 digits of this number is 7 and 2. If I add 7 and 2 together, it's going to give me 9. And 9 can be divided by 3. That means 672 can be divided by 3. Then this also, of course, is a 2-digit number. If I add 4 and 8 together, that will give me 12. 12 can be divided by 3, so that will mean that 48 as well can be divided by 3. So I'm going to use 3 as a common factor for 672 and 48. So I'm starting from my denominator like I did in the first example. So 3 in 4, that will give me 1, remainder 1, and then 3 in 18, that will give me what? 6. So I've reduced 48 to 16 using what? 3. So I'm going to do the same thing with the numerator. 3 in 6, that will give me 2. And then 3 in 7, that will still give me 2, remainder 1. And then I have 12. So 3 in 12, that will give me what? 4. So 3 in 672, that will give me 224. So I'll write out my new number, which is 224 over 16. So now 4 ends this number. That means that 2 can divide it and 2 can divide 16. So I'm going to use 2 to break it down. So starting from 16, 2 in 16, that will give me 8. And then 2 in 2 here, 1, 2 in 2, 1, 2 in 4, 2. So that means 2 in 224 will give me 112. So my new number is 112 over 8. So now, the common factor of 112 and 8 is still 2, because 112 is an even number, 8 is an even number. So 2 can still divide them as their common factor, can still reduce them. So 2 in 8, that will give me 4. And then 2 cannot go in 1, so I will attach 1 and 1 together, making 11. So 2 in 11, that will give me 5, remainder 1. So if I join the 1 to these 2, that will make it 12. So 2 in 12, that will give me what? 6. So I have 56 over 4 as my new number. 56 over 4. With 6 ending 56, that makes it an even number. So that means 2 can divide 56, 2 can also divide 4. So I will say 2 in 4, that will give me 2. And then 2 in 56, that will give me 28. So because 2 in 5 is 2, remainder 1. If I join the 1 and 6 together, making it 16. So 2 in 16 is 8. So I have 28 over 2 as my new number. Now that I have 28 over 2, 2 itself is a factor of itself. So I'm still going to use 2 because 28 is an even number and 2 is an even number. So I'm going to use 2 itself as a common factor to divide 28 and 2. So 2 in 28, that will give me 14. And then 2 in 2 itself, that will give me 1. So I have 14 over 1 left, which equally will give me what? 14, because any number divided by 1 will give you the same number. So 14 over 1 will give me what? 14. So successfully I have divided 672 by 48 using what? Reduction method. Look at the levels of the reduction from here to here. So and then now example number 3. We are dividing multiples of 10 because the number ends with zeros, and then this one also ends with 0. So both the dividend and the divisor ends with a 0. So now to divide multiples of 10, we still follow the same method. We express the number as fraction. So I'm going to have 31,500 over 450. Now, how do I go about reducing this number? First of all, because they have zeros in common. So I'll first of all strike out the numbers of 0 they have in common. There is 1 0 here, so 1 0 in the denominator, we cancel 1 0 in the numerator. So now that I've struck out what they have in common, so I'm going to write what I have left, which is 3,150 over 45. Don't forget that the 0 here has cancelled the 0 here. So I have 3150 left in the numerator and then 45 left in the denominator. Now the next thing for me to now find out is their common factor. That is a number that can divide both 3150 and 45 at the same time without any remainder. So the number is basically 5. According to the divisibility rule of 5, 5 can divide all numbers that end with a 0 and that ends with 5. 5 can divide all numbers that end with a 0 and that ends with 5. So basically 5 is a common factor of the numerator here and the denominator. So I'm going to use 5 to reduce the number. So 5 in 45 is 9. If you're conversant with your multiplication table, you will know that 5 times 9 is 45. So 5 in 45 is 9. Then to divide 3,150 by 5, of course, I'll take it one by one. So 5 cannot go in 3. So what do? I will attach 3 and 1 together, making it 31. So 5 in 31, that will give me 6, because 5 times 6 is 30. So remainder 1. So the remainder 1 will be attached to this 5, making it what? 15. And then 5 in 15, that will give me what? 3. So I have 0 left. 5 in 0, of course, will give me what? 0. So my new number is 630 over 9. Now, this number ends with a 0 and we have 9 in the denominator. So what's still their common factor? Now, what number can divide both of them? Of course, 2 can divide 630 because it ends with a 0 according to the divisibility rule of 2. 2 can divide all even numbers, numbers that are even numbers and numbers that end with a 0. But 2 cannot divide 9. So let's consider 3. Can 3 divide 630? Yes, because 3 can divide 6, 3 can divide 3. So 3 can divide 9. So 3 is your common factor here. So I'm going to use 3 to reduce them. So 3 in 9, I'm going to have 3. Now, I've reduced 9 to 3. So 3 in 9 is 3. Then I'm going to use the same 3, which is the common factor, to divide 630. So 3 in 6, I will have 2 without any remainder. And then 3 in 3, I will have 1 without any remainder. And then 3 in 0, of course, will give me what? 0. So I have 210 over 3. Now, can 3 still divide? Is 3 still a common factor? Yes, 3 is still a common factor because 3 can go in 21. So I will still use 3 as a common factor to reduce the two numbers. So 3 in 3 itself will give me 1. And 3 in 21, that will give me 7. Because 3 times 7 is 21. And 3 in 0, of course, will give me what? 0. So my new number will now be 70 over 1. So any number divided by 1, as we said, will give you the same number. So 70 over 1 is still the same thing as 70. So successfully, I have divided 31,500 by 450, which my answer is 70. So that is that about division of whole numbers using reduction method. If you are new to this channel, please kindly click on the subscription button below this video to get notified of more academic lessons like this. And if you are a returning subscriber, we say thank you for your love and support always. I will see you in the next lesson.